Hello, welcome to the video lecture on binary search. In the present video, we learn searching, types of searching, binary search program, complexity, and a comparison between linear search and binary search. Searching algorithms are designed to check for an element or retrieve an element from a data structure where it is stored. Based on the type of the search operation, these algorithms are generally classified into two categories. One is sequential search, second is interval search. In the sequential search, the list of array is traversed sequentially and every element is checked. Example is linear search. In our previous video, in detail we have discussed about the linear search. And in today's video lecture, we are concentrating on the second type is interval search. These algorithms are specifically designed for searching in sorted data structures. These types of searching algorithms are much more efficient than linear search as they repeatedly target the center of the search structure and divide the search space in half. Example is binary search. In the present video lecture, we learn about the binary search concept and a program on it. Here, in this slide, the concept of the binary search has been explained. Let us see into the diagram. Here, a given list is available. So, starting from 0 to 9, there are certain elements. One important point that what you have observed is that the list is already sorted in an ascending order. So starting from 2, 5, 8, 12 like that, 91, this is a sorted list. So this is the essential feature of the binary search. So the binary search is performed on a sorted list, whereas linear search is performed on a unsorted list. By taking the search on a sorted list is a very convenient method that we learn from the next step. Now, let us assume that the searching element is 23 in the given list or sorted list from starting from 2 to 91. And now, in this method, what is the approach? We find out three terms. One is known as lowest index, second is called middle index, and third one is called highest index. The leftmost index, that is 0, is the lowest one in the beginning, and the size of the array 1 less than the size of the array is the highest index. Now we compute middle index by taking the integer division of lowest index and highest index, that is L is equal to 0 and H is equal to 9. L plus H is equal to 0 plus 9, that is 9, and half of that one is that 9 by 2. 9 by 2 means actually it is 4.5, but in integer division it becomes only 4. So thus the middle index is now 4. So that means what we did, we took the lowest index, we took the highest index currently, and we could find out the middle index as 4. Now whatever the element that we are searching, first that element is searched with the middle index element. If there is a match, then immediately we get the success and we say that search is successful. Simply with one comparison we are getting the success. And other possibility is that whatever the value that we have taken, that may be either less than or maybe greater than. Here, by having a sorted list, the advantage is that if the given key element is less than the middle index element value, then definitely it should be only on the left hand side of the middle element, and then we could search only here itself by leaving the other portion. Similarly, suppose whatever the value we have taken, and if that value is compared with the middle element value, and if it is greater than that, then definitely the element will be only on the right hand side of the middle element array, and we have to search in this area and no need to search for the other portion. So in that way, in total what we are doing, only we are searching the half of the list, not the total list. That is the advantage. Now in the present case, as search is 23, 23 is greater than 16 means definitely it will be available on the right hand side only. Okay, that means now we start from here only. So other list is not at all required, and now we take it as a fresh list. In the fresh list, what happened? Now the lower element is not now 0 because it is the beginning. Now lower element is becoming 5 and highest is as it is 9. There is no change. Now again we compute middle element. What is the principle for middle element? L plus h by 2. So here L is 5, h is 9, 5 plus 9 14, 14 by 2 is 7. So 7 is the middle element. Now let us come to middle element 56. Now what is the key element? 23. Now we compare the 23 with 56, and what we are observing, it is less than 56. First thing is that there is no match. Number one, it is less than 56 means now only elements on the left hand side of this one can be considered for search. These two can be overlooked. And now here in this list, this is becoming the new lowest index, and it is becoming the 6 is becoming the highest index. So 5 plus 6 is 11 by 2 means 5 itself. So that means now we are comparing the 23 with the fifth index element. Now we are finding a match here. That means the search is successful, and at position 5 we could find out the element. But the main advantage is that we have minimized the number of comparisons because as the list is already sorted out. So this is the basic principle of the binary search. So by implementing this binary search, we can write a program. Here we have taken the elements lowest as first, highest as last, and middle element as middle. Now n is the number of elements, and search is the element that we are searching for, and array is the given list of elements. Now printf enter the number of elements, that is n. So how many elements we are required in the array. Now printf enter the integer n. So therefore with the scanf we put the values of n. Now c is equal to 0, c is less than n, c plus plus. With this we are using a for loop, and in this for loop every time we are entering the elements of the list. So now when this for loop is over, all the elements are stored in the memory, and now we are checking whether you have properly stored or not as per our requirement. We are using the printf statement to find out whether you have entered or not. After that, next one is that which element we have to search. That will be with the help of the scanf statement. We are giving the key element or search element. Now up to this what happened, we have declared the array, we have stored the elements in the array, we could find out the size, and we have given the key element which is to be searched in the given list. But anyhow we should see that the list is already sorted. That is very, very important. So here we assume that already the list is sorted. Now once we assume that list is sorted, our work will be very simple for next calculation. In the beginning, first will be 0 and last will be 1 less than the size, and we can calculate the middle element. Now, while first is less than last, why this logic is given? This will help us to check out whether all the elements are exhausted or not while searching the list or sublist. That is the purpose of this one. So while first is less than or equal to last means still we will be inside the list. Once the condition fails means all the elements are exhausted in the list and we should come out. And now what we are checking, if array middle is less than search, then first is equal to middle plus 1. Else if already middle is equal to search, found the element at location and search is successful, break we come out of it. Otherwise, last is equal to middle minus 1, and middle is equal to first plus last by 2. Again we are repeating the process, and finally again we are repeating the procedure. So that's what happens. By repeating the procedure for the several number of times in a repeated function process, we can find out the element, and this procedure is called binary search. Now enter the number of elements 7, enter 7 integers, and the values are all these like this, and enter the value to be found, that is 11, and 11 is compared with all this one, and element 11 is found at position 5, hence search is successful, and 11 is found at 5. Now let us have a comparison with linear search and binary search. A linear search scans one item at a time without jumping to any item. The worst case complexity is big O(n), sometimes known as big O(n) search. Time taken to search elements keep increasing as the number of elements are increased. A binary search, however, cut down your search to half as soon as you find middle of the sorted list. The middle element is looked to check if it is greater than or less than the value to be searched. Accordingly, search is done to either half of the given list. Important differences between them. Input data needs to be sorted in binary search and not in linear search. Linear search does the sequential access, whereas binary search accesses data randomly. The time complexity of the linear search is big O(n). Binary search has time complexity of big O log n. Linear search performs equality comparisons. Binary search performs the ordering comparisons. Thus, in the present video, we learned the searching, types of searching, binary search program, complexity, and linear search versus binary search. Thank you all.